Hello viewers, this is Jeyapradha, Assistant Professor, Department of Computer Applications, SFRC. Today I am going to discuss about deadlock and its four conditions. Deadlock is a situation where two or more processes are stuck forever because each one is waiting for the resources held by the other one. Let's discuss in detail about the four conditions which leads to deadlock in detail. These are the objectives for learning the topic. First one, understand the fundamentals of multi-process system and deadlock. Then you have to identify the four necessary conditions for deadlock, analyze the system scenarios and determine deadlock. Last one, we have to evaluate the deadlock avoidance strategies and propose a solution. Before moving to the main topic, let's discuss the multi-process system. So first one, what is multi-process system? It is a system that has two or more CPUs are working together to execute process simultaneously. In this system, multiprocessors share main memory, I/O devices and OS. Some key characteristics which follows in multiprocessors are parallel execution for higher performance, shared memory for faster inter-process communication, single OS image for one operating system controls all the CPU functions, load sharing for what can be distributed across multiple processors. For example, a web server using two CPU, that means CPU 1 and CPU 2, CPU 1 for process the database queries and CPU 2 for manages the file operation. So the key point or the key idea behind that is a multi-process system improves parallelization but with proper resource management because it can lead to deadlock. Again, the deadlock is a condition where two or more processes are permanently blocked because each process is waiting for a resource held by another process and none of them can proceed. Let's go to the topic deadlock. Deadlock is a situation where a set of processes are stuck forever because each one is waiting for a resource held by another process in the same set. No one can move and no one can finish. An OS system model comprises a fixed number of resources that must be shared among different processes. For example, some resource types are memory space, CPU cycles, directories and files, I/O devices, etc. It worked under the standard mode of operations in request, use and release. So if any process may use a resource only in this in the following sequence. First one is request, which means when the request cannot be approved immediately, the resource requesting for the job must wait until it can obtain the resource. Second one, use. The process can run on the resource, which means for example, when the resource is a printer, its job or process is to print on the printer. Final third one is release. The process releases the resource once it completes its execution. Next one, how does deadlock occurs in OS? Deadlock arises when process holds some resources while waiting for others. Look at the given example diagram. Process P1 holds resource R1 and request for R2. The same time the process P2 holds resource R2 and request for R1. So in this situation, neither process can proceed, which leads to a deadlock. The four conditions which leads to a deadlock condition, that are all four must be present at the same for a deadlock to occur. The first one is mutual exclusion. At least one resource have to be executed or processed at a time. For example, a printer or file lock system. Second one, hold and wait condition. Hold and wait means a process is holding at least one resource and waiting for additional resources that are currently held by other processes. Third condition is no preemption, which means resources cannot be forcibly taken away from a process. They must be released voluntarily after use. Fourth condition is circular wait. Circular wait is a cyclic process where each process is waiting for a resources held by the next process in the cycle. For example, P1 holds P1 waiting for P2, P2 waiting for P3 and the P3 again waiting for the P1 hold resource. The key idea behind that is if you want to prevent any one of these conditions, deadlock cannot happen. Let's see one by one. First condition is mutual exclusion. Mutual exclusion is a condition in an OS where only one process at a time is allowed to use a particular resource. If another process requests the same resource while it is already in use, the requesting process must wait until the resource is released. For example, a printer can print for only one process at a time. If process P1 is using the printer, means process P2 must wait until P1 finishes and releases it. So the solution to avoid the mutual exclusion is it cannot be completely removed or for non-shareable resources, but carefully use of locks, semaphores and shareable resources can prevent deadlock and starvations. So semaphores are variables used for control access to a shared resources. It ensures mutual exclusion without necessarily waiting for shareable resources. So another one solution for the mutual exclusion is critical section problem. So to solve mutual exclusion safely, we have to satisfy three conditions. Mutual exclusion, first one, only one process in critical section at a time. Then we have to progress. If no process is in the critical section, then one waiting process is allowed to enter. Third one, bounded waiting. So no process waits indefinitely to enter the critical section. So these are the solutions. We have to prevent deadlock and starvation while maintaining mutual exclusion resources. Second condition is hold and wait. So it occurs when a process is holding at least one resource and waiting to acquire additional resources that are currently held by other process. Example, suppose we have process 1 holds resource 1 and the process 2 resource holds 2. We have to execute the steps in the following manner. P1 request R2 must wait because P2 holds it, and P2 request for R1 it wait because P1 holds it. So both the processes are holding resources while waiting for others. This condition leads to a deadlock. The solution to this is to eliminate the hold and wait condition. There are two common approaches. First one is require all resource at once. Second one is release held resources before requesting new one. Through first solution, a process must request all the resources it will need at the start. If all requested resources are available, they are allocated to it. If not, the process waits without holding any process. Second method, if a process needs additional resources while holding some of the resource, it must release all currently held resources, then request all the required resources again. Third condition is no preemption. So no preemption is one of the four conditions for deadlock. It occurs when a resource cannot be forcibly taken away from a process once it has been allocated. The process must release the resource voluntarily after it finishes using it. For example, suppose we have process 1 holds R1 and process P2 needs R1 but cannot get it since R1 cannot be forcibly taken from P1. P2 must wait until P1 releases it voluntarily. So how to prevent no preemption condition means it have two solutions. First one is preempt resources from waiting process. The second one is rollback. So if you want to preempt the resources, if your process cannot obtain all the resources it needs, so the OS can temporarily take away resources it's already hold. Second condition is rollback. The preempted process is rollback to some safe state and will request another resource again later. The last condition is a circular wait. So it is a condition where a set of processes form a cycle, each waiting for a resource held by the next process in the cycle, causing deadlock. For example, P1 waits for R2 held by P2, P2 waits for R3 held by P3, P3 waits for R1 and held by P1. This forms a circular chain of waiting. So none of the process can proceed, resulting in deadlock. So solution to the circular wait is we have to break the circular chain of resource waiting. This can be done by imposing a total ordering on resources, which means first you have to assign a unique number to each resource. For example, R1 resource have 1 and R2 resource have 2, like that. Second step, we have to forcefully process to request resources in increasing order, which means a process can only request a resource with a higher number. then any resource it currently holds. Finally, we have produced the result. Circular wait is impossible because the request always move up the order. No cycle can form. Hence, the deadlock is prevented. So, conclusion. Deadlock is a situation where processes are permanently blocked waiting for each other's resource. Cause it occurs only when all four necessary conditions, which means mutual exclusion, hold and wait, no preemption and circular wait are present. The impact of deadlock is it leads to system inefficiency and as affected process cannot be proceed. How we have to prevent means by breaking any one of the four conditions, deadlock can be avoided and prevented. Thank you for watching.